Meta has just revealed something really big in the world of AI. It's called Refrag. And it's not just a small update, it's a huge breakthrough. Imagine an AI model that can process information up to 31 times faster than before and can also handle 16 times more data in one go. That means AI will no longer struggle with long documents, big conversations, or huge sets of information. So now let's talk about what exactly is Refrag. The full form is representation for Retrieval-Augmented Generation. Now that sounds technical, but let me explain it in plain words. Refrag is a new system created to make AI much faster and smarter, especially when the AI has to read or process a lot of information at once. It was developed by Meta Superintelligence Labs together with researchers from the National University of Singapore and Rice University. These are some of the top minds working on AI today, and they came together to solve one big problem: how to make AI handle really huge amounts of text and data without slowing down or getting stuck. The goal of Refrag is simple: to give AI a kind of superpower so it can look at more information, understand it better, and respond faster. Think of it like upgrading a regular car into a supercar. The supercar doesn't just go faster, it's also designed to handle more complex roads smoothly. In the same way, Refrag upgrades AI so it can deal with very long documents, big conversations, and lots of data, all while giving answers much quicker. To understand why Refrag is such a big deal, let's first look at the problems with the AI models we currently use. Most large language models or LLMs have something called a context window. This is basically the amount of text they can remember or look at one time. For many popular models, this is only about 4,000 to 8,000 tokens, which is roughly like a few chapters of a book. If you try to give them a really long document, like a full research paper or even a whole book, they start forgetting earlier parts or they just can't process it at all. Another issue is speed. When an AI has to read and process long documents, it becomes painfully slow. Imagine waiting forever just for the first word of its answer. That lag is frustrating, especially when you want quick results. There is also a system called Retrieval-Augmented Generation or RAG, which is supposed to help AI by letting it search through external information like a database or the internet and then use that information to answer questions. But here is the problem: when the AI pulls in a lot of text, it ends up with huge chunks of data that it has to go through. Instead of helping, this sometimes slows everything down even more. And this is where Refrag comes in. It solves these issues by compressing the data in a smart way and then speeding up the decoding process, where the AI actually generates an answer. With Refrag, AI can handle much longer documents and still respond faster, making long context RAG finally usable in real time. In simple terms, it allows the AI to read more, understand more, and reply quicker all at once. Now let's break down how Refrag actually works step by step. Don't worry, I will keep it simple so it's easy to follow. The first big idea is chunk compression. When the AI retrieves a lot of text, instead of trying to read everything word by word, Refrag breaks the text into tiny groups of about 16 tokens each. Once the text is split into these small chunks, each chunk is covered into something called a dense embedding vector. In plain words, it's like turning a sentence into a short, meaningful code that still represents the main idea. By doing this, the AI doesn't need to carry around the full text anymore. This reduces the overall length of the input by up to 16 times, which saves a lot of space and effort, right? Next comes efficient decoding. Normally, AI models process raw tokens, which is slow and uses a ton of memory. But with Refrag, instead of passing all those tokens into the decoder, the AI just uses the compressed embeddings. This is like giving the AI a summary instead of the whole book. Because of that, the memory use and computing power needed drop massively, and the AI can generate answers much faster. But here is the smart part: selective expansion with reinforcement learning. Refrag doesn't just blindly compress everything, it knows that some parts of text are too important to compress, like specific numbers, rare terms, or very detailed facts. For those, it keeps the raw tokens as they are. This way, the AI doesn't lose accuracy or important details while still saving time and energy and the rest. And when you look at the performance numbers, the results are impressive. Refrag allows AI to handle 16 times longer content compared to before. It makes the time to first token up to 30.85 times faster, meaning you get the first word almost instantly. It also improves overall throughput by 6.78 times, which means the AI can process more requests in less time. On top of that, it shows 9.3% better accuracy compared to an earlier method called CEPE. Now let's talk about how Refrag actually performed when it was tested. The researchers didn't just make bold claims, they ran Refrag through tough benchmarks to prove its power. They tested it on well-known datasets like books, ARXIV research papers, PG19, which is a large collection of long novels, and Prooffile, which contains formal logic and proofs. These are all challenging datasets because they involve long, detailed, and information-heavy text. And the result? Refrag constantly outperformed the older methods, also called baselines. For example, in long document summarization, it did a much better job at keeping track of details and producing accurate summaries, even when the input text was very long. This is a big deal because most AI models usually forget or lose track when the document is too long. It also showed big improvements in multi-turn conversations. Normally, when you talk to an AI for a long time, it starts to lose context and forget what you said earlier. But with Refrag's ability to handle much longer context, it was able to keep up with extended conversations and still give relevant connected answers. Another important result came from weak retriever scenarios. This happens when the AI pulls in a lot of extra text that might not even be relevant to your question. Normally, this confuses the model and slows everything down, but Refrag's compression and selective expansion made it better at filtering through the noise and still producing accurate answers quickly. But now, I would love to hear from you. What do you think? Is Refrag the future of AI efficiency? Do you see it changing the way we will use AI in our daily life? Let me know your thoughts in the comments below. And if you found this video useful and easy to understand, don't forget to like the video, subscribe to the channel, and hit the bell icon so you don't miss more updates on the latest AI breakthroughs.